I'm Dan Christianson. I'm the Director of Engineering for the supply chain here at Hill Air Force Base. And we own about 30%, a little over 30% of all the parts in the Air Force, a little over 30,000 individual parts. And so we look at aircraft and radars and a bunch of other things as items that are a large conglomeration of parts that are flying in close formation. So it's not a real assembly to us. We look at it as individual parts. Now, I have mostly fighters and then some space-based control systems or space control systems that are ground support, and a bunch of trainers and a bunch of other things. But my 30,000 parts do that. Plus, I have all the landing gear for the Air Force. Anything that decides it's going to fly and land, we pretty much have that. I also have the sustainment of a number of other training systems as well. And putting all that together, it ends up being a whole bunch of stuff. Now, I grew up as a design engineer for Lockheed Martin when I was a kid. For the first 10 years of my career, I worked for what's now Lockheed Martin. Now, it was at that time General Dynamics, and we're going to go through some of the discussions about how organizational acquisitions make sustainment problematic. That'll be one of my thoughts. But more importantly, literally, I was a kid right out of school when I started on F-16 and then moved into F-22 and F-35. And interestingly enough, the F-35 was actually on the drawing boards before the F-22 because, you know, of course, it looked a lot like the F-16. It looked still a little bit like the F-16. And the construct was that we were going to do a single engine fighter, and that became not a desirable choice, and so F-22 became the design criteria, which became the YF-22, which started out as ATF, became the YF-22, and then ultimately is fielded. And just points of note, the F-22 first flight was just over 30 years ago, earlier this week, and the F-35 first flight was just over 20 years ago on the 24th of October. So just so you know, these aircraft that we think of as brand new and off the shelf really aren't. And if you compare that back to the concept in World War II, where an aircraft total product life cycle might be 2 years, we're in a different world. And there's a lot of reasons why some of the things of the past might be the things for the future. And that's kind of my concept is that sustainment is rapid refresh. It makes our lives so much easier if we will spend some time and think about how to make a rapid refresh of that weapon system. And that's basically my thought and construct for you. It is to sustain systems. We're going to talk a little bit more about that as we go through. And I have in my portfolio aircraft components that are over 60 years old. And some of them are going to be in use for the next 40 years. A B-52 plans on being operational today. They have a horizon of about 100 years from first flight. And, even the new systems, as we talk about them, aren't really new. It's the quick turn things that we have aren't very quick turn. So if you could bring up my slides and then we'll, excellent. I'm Dan Christenson. I represent the supply chain for the Air Force. And I'm sitting in for Thomas Lamb today, who couldn't be here. But I've been working this particular problem on the electronics side for a very long time, almost 15 years now. And what's stunning is that electronics in general are a lot more reliable than anyone ever thought they were going to be if they were designed for the environment they were going to be used in. And that's a key criteria, if they were designed for the environment that they're used in. Now, if not, the bathtub curve engages, and it engages very rapidly. Next slide. I'm going to talk about why we want to do rapid refresh, because as I said just now, the electronics will last a long time, but it doesn't necessarily give us what we really want. Very quickly, even the day after you field the system, the users are off looking for that next shiny object that Peter was talking about, and they suddenly say, "Oh, that F-22 is no longer doing what we want it to do. We would like to do more." And so when they come to the F-35, they have 10 years to think about what more they'd want to do, and they pour all of that into a much smaller aircraft. So acquisition, at that point, when they start doing the primary acquisition, they're saying, okay, we're going to design an aircraft that we claim will be only around for 10 years, but we really believe we want to have that capability be beyond what anybody else can do 30 years from now. And if you look at the F-22, for the most part, that's still true. 30 years out, it is still at the bleeding edge. There are not many weapon systems in the world that can compete with it. Now, if you look at it internally, though, you know, the one thing that never changes in a weapon system is the basic infrastructures. And once you decide something that turns into infrastructure, you can't really change it. For example, if you decided you're going to talk with 1553 to all of your different LRUs between them, you'll be talking to them that same way 30 years from now. It's very difficult to change all of the LRUs simultaneously, so that particular data link is removed. So the acquisition community designs thinking that they're going to look 30 years out and they're going to know. Well, the reality of it is they don't have that good a crystal ball. And so when they're in the development, what they really do as they're developing the aircraft, the sustainment budget itself is regularly rated for non-sustainment purposes, because that's the only budget that they have in their trade space. So as a result, we don't get the information that we really need. Now, the current DMSMS cases, and I think all of us know how that goes too, quite often, if we could have fixed it when we recognized it was there, we could have saved a bunch of money and pain, just as Peter said, and just as Ethan had indicated. That pain cycle could be very much avoided if we are able to do things when we know they need to be done. But unfortunately, right now, DMSMS cases, if they are only causing availability, you can't fix them. You know, availability problems. What you have to do is get to the point where you have a mission capability degradation. And at that point, then you can begin investing dollars. And last but not least, of how we do it now, we buy data item descriptions instead of buying development artifacts. Truthfully, that construct was designed by contracting officers to be able to know what it is that they buy and get it where it's fully defined. In which case, what actually happens is most useful information, or a lot of the useful information that the design team had about the weapon system, and especially their train of thought that is really inculcated into those development artifacts, those are deleted. And then we create this thing, it's called artificially a data item description, and that's what we buy. Next slide. So how should we do it? Well, that 30-year aircraft that we call the F-22 would have been a lot better off if we had turned around and at year 10, redesigned it. In fact, from first flight to first aircraft was 10 years. The first production aircraft was, well, it was 7. And then at that point, you know, since then, 23 years later, we haven't changed it very much. And what we really need to do is have a much shorter cycle. And the reason we want to have shorter cycle is because the short pole in the tent, which really drives the long pole in the tent, is the electronics life cycle, which, you know, in reality, many of us recognize is about 18 months. If you go look at the iPhone that's in front of me that I've had for several years, there's not a single component in it that I can buy. That life cycle replicates itself inside of the DoD systems, only slightly, having only a slightly longer cycle. And yet we attempt to avoid having a midlife upgrade until year 30 or more. And even though we tell everybody it's only a 10-year aircraft, we act completely differently than that. So we need to fund and facilitate those resolutions so that we can have short-term resolutions to issues and facilitate future resolutions that we know are going to come our way. I don't want data that is just a data item description. I want the information that the engineers used so I can get their view of the world at that time. And then later, I can go do something else. Next slide. Now, the challenge is that the life cycle is always longer than the originally programmed life cycle. And we don't plan for them to be longer, even though we know they are. B-52 never thought that it was going to be flying for a century. There was no plan for it to fly for a century. There was a plan for it to fly for 10 years. And that's a concept that really we ought to utilize and say, okay, if it's not going to fly, how do I do the refresh, the technology refresh that's necessary to be able to keep it up to date? And furthermore, that I can do the refresh so that we have current technology in the weapon system, even if we don't add additional capability. We need to be doing those programmed cycles so that we can be able to keep the capability to maintain it. Now, it takes a long time to field new systems. As I mentioned, from first flight of the F-22 to the actual production asset was 7 years. And it was in design for about, you know, it was on a drawing board a decade before, as was the F-35. And those long terms are all tied back to this concept of we're trying to capture everything that's in every shiny new object and every new design. And that's a fallacy of our design criteria. It's a fallacy of our acquisition construct to be able to shove all of those things in there that we're going to have to invent. Instead, we need to go back and say, what can I do with today's technology? And then turn around and do another cycle to be able to catch that new idea and add a new idea each time. Now, by doing this acquisition life cycle that we look at for 30 years, there's no money left really for the DMS MS issues that actually occur in full up operation and sustainment. We don't have that. Now, OEMs are not contracted to design for those operation beyond the program date, and they don't. The fact is, once I was told, when I'd sit there and said, okay, these things are the things that we need for long term, I was told, stand by, we don't have that on contract. You can't do something that's outside of the contracted item. Next slide. Now, OEMs themselves don't end up having a life cycle of their own. Each of them changes in their life cycle. And while companies like McDonnell Douglas no longer exist, at least for the F-15 absorbed into Boeing, Lockheed, General Dynamics, The F-16 portion and F-22 and F-35 were absorbed into Lockheed Martin, interestingly enough. A-10, Fairchild Republic, we retired it twice and we still have it in the flight in use today, and it is one of the favorite aircraft by those forward people in forward locations. Boeing, Task, started out as Boeing, ICBM did. Boeing went to Task, TRW, Northrop Grumman, and now BAH. Lots and lots and lots of things like that. B1, you can see during Jimmy Carter, the cancelization, and of course, we resurrect it at a later date and try to make it work. So the DMSMS, as we do, and we do those redesign efforts, late to need without the developmental artifacts, they just go crazy in terms of costs, because I'm now not doing a redesign effort. I'm actually doing a re-engineering effort. I'm not just looking at what really I know it has to be. I'm turning around and having to figure out what it really is before I can go redesign. Next slide. So the overcoming those challenges, things that I would tell senior executives, things I would tell the Air Force, senior leadership, and AM, and to some degree I'm beginning to be heard, change the program focus from a 10-year, and really do implement a 10-year modernization cycle. Don't just design it for 10 years. Actually facilitate that modernization at that point. Design for sustainability has got to be a primary criteria, which means we actually have to have the data that we need to be able to do it. Everybody says, well, you don't use any of that data. Well, that's false. But realistically, if that data isn't available, we can't do, we are in a world of hurt trying to go back and do the long-term sustainment. And we have to preserve that long-term sustainment budget throughout the development. It's the front end that makes a difference as to what's going to happen on the back end. And it ends up needing that money to be fenced from the rest of the acquisition budget, so it can't be used as trade space for the acquiring program manager. He's doing it with all the right intentions, but it ends up being a long-term sustainment bust. Next chart. 3-year sustainment budget, we need a short-term budget as well that says, okay, once we have it out there, there's going to be some things that immediately emerge. We need to be able to fix those. And this is what we have to do in the supply chain, and we need to maintain that budget. In a given year, I spend somewhere between $30 million and $270 million doing these redesign efforts, depending on what they are. We need to purchase the development artifacts that are available at the time, the real engineering artifacts that were defined at the time, and move on from there. And we got to incentivize contractors to design items that can be supported and sustained throughout our design efforts, meaning that we need the data, we need to be able to have people that can be there for us at a later date. And then we need to repeat. Anyway, ultimately, capability enhancement, sustainment upgrades, all of those things have got to be done in another phase and repeated again and again and again. And for B-52, we would repeat it 10 times to get it through to its end of its life. F-35, we should have already, or F-22, we should have done twice already, and F-35, we should have already done once, neither one of which have really been addressed yet. Next slide. So, in summary, incremental capability updates, we need to do it every 10 years, buy the artifacts, development artifacts when they're available. Don't try to reinvent them after it's a late date. And then we need a fenced logistics budget. And the problem that we have, and there's a bunch of questions that I see growing here, and we'll see them in the breakout session, or at least in the following session with all of us on the panel. But how do you get there from here? It's difficult. It's difficult because it's a mindset change that has to happen within the programming of the acquisition community. Because otherwise, people like me don't have what we need when we need it, and we have to go back and reinvent it. And that is not trivial. those expenses are, you know, I spend about 80% of the Air Force's TOA between us and the supply chain. And just my little location, I did that 30 million every year and 270 million max. If you multiply that by 3, you get an appreciation of what kind of money we're talking about to do these re-engineering, redesign efforts. And with that, I'll turn the time back to Ethan and say, you know, he'll tell me that I'm eating up my time and it's far gone.
No, you're perfect. You're perfect. You're bang on. You know, while we're setting up the next presentation, I did want to just kind of throw something out, and I wanted to ask you. I thought it was really interesting that you split up your suggestions between kind of senior executive leadership and kind of program managers and supply chain. And I'm wondering, do you see a disparity between kind of how they see the problem, or you think that they're generally pretty well aligned?
I honestly think that they all see the problem in a similar way, but I do not believe that the solutions are the same for each. A sustainment organization has at its core, we've got to maintain the existing functional baseline of that weapon system. We don't have the right responsibility or opportunity to go change it. The SPOs have as their responsibility the chance to buy it in the first place and then modify it along its life cycle. And they have many, many more flexibilities as a result. The senior leadership inside of inside of OSD, inside of other places, the Robin Brown folks and higher, those are the people that make the policies that put us in this place where we can help change the way real things happen. A simple one. Supply chain was precluded from being able to do updates for electronic components in some cases because we couldn't buy the parts and the parts that we designed in the time that the parts were available. Remember, we're running out of those components that you're going to go use inside of your place. If I tell you how many I'm going to buy and build, you can't buy those production parts and then turn around and wait until I buy the assembly. You have to have there's got to be a way that we can go front end load our budgets, because otherwise I'll buy one and then it'll be, like I said, the electronics has an amazing product life cycle, and then I'll turn around and 10 years later buy another one, and by then Ethan will be out of business because he's already invested in all of the parts that were necessary to build that new item that was supposed to be the replacement. And that policy we recently rethought, and they're working through that concept for what's called an improved item development, IRP replacement program, so that we can go, especially for electronics items, be able to budget for the entire build, buy them up front, and then put them on the jet as needed.
Thank you. That's good stuff, Dan. You know, really, really thoughtful response. And it sounds like there is some policy and practice progress happening to, you know, address some of these longstanding challenges, specifically around electronics. Good stuff. Thank you, sir. I remind you to go ahead and submit your questions to info@gdca.com.